educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the construction and interpretation of graphs. In the last lesson, you learned about why it is important to represent data in different ways. Tables are often used because they are concise and exact. Different types of graphs can be used to give information in a way that is attractive and easy to interpret. Today, we will learn about other ways to organize and present data such as histograms, frequency polygons, and frequency curves. Are you ready, students? Let us begin. You probably recall histograms from previous grades. There is an important difference between a histogram and a bar chart. A bar chart shows qualitative data along its x-axis or variable axis. In this example, the years that are on the x-axis are not consecutive. They are simply the years for which data has been collected. A histogram, on the other hand, illustrates continuous data, so the x-axis is a continuous number line. This histogram shows a continuous number line from 1 to 21 along the x-axis. Students, let us review how to construct a histogram. The first step is to construct a grouped frequency distribution. This will involve drawing a frequency distribution table like the one seen here. The second step is to locate the class boundaries along the x-axis. Here, we see that the class boundaries are the lengths. The third step is to determine the class interval by the width of the bars. Based on our data, the intervals are 1 centimeter. Finally, the y-axis is added, and the height of each bar is marked to indicate the frequency. Another way to represent grouped data is by drawing a frequency polygon. When you draw a frequency polygon, you plot the midpoints of the class intervals on the x-axis and the frequency on the y-axis. Then, you join these points together by using consecutive line segments. Students, I would like you to try to draw a frequency polygon. Here is a table that shows the ages of patients who attended a medical clinic on a Saturday morning. Please use the information in this table to construct your graph.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Does your graph look like this one? Well done. As you can see, the midpoints are noted along the x-axis. The number of patients, the frequencies, are noted along the y-axis. Since there were 3 patients with ages in the 17.5 class, a dot is placed at this point. The ages of 17 patients fell in the 22.5 class. So, another dot is placed at this point. A line is drawn to connect the dots, and so on. It is important to note that dotted lines are drawn at both ends of the graph in order to close the polygon. These lines are dotted to show that they are not part of the data. Frequency polygons are more meaningful if comparison data is superimposed on the same graph. In the example we just worked on, data from another medical clinic could be plotted on the same graph. In that way, we could compare the ages of patients at 2 different clinics. Students, one more way to represent grouped data is by using a frequency curve. A frequency curve is simply a frequency polygon that has been smoothed out. Instead of consecutive line segments, the graph appears as a smooth curve. One type of frequency curve is called an ogive. An ogive is a cumulative frequency curve. To draw an ogive, you need to use a cumulative frequency table. In this example, we see a table of students' marks. There is an additional column on the right that shows the cumulative frequency. Cumulative frequency gives us more information on the data as a whole. For instance, we can now see that there are 30 students whose scores are less than or equal to 30. To draw the ogive for this table, the cumulative frequency is plotted against the upper class boundary rather than the midpoint. The first point is plotted at 3 for frequency and 20 for value. The next point is plotted at 20 for cumulative frequency and 25 for value. We continue plotting our cumulative frequency until the curve looks like this. Students, please look at what happens when we plot the regular frequency curve for our students' marks over top of the ogive curve. Although we have used the same data, the graphs look very different. Students, why would you choose to use a cumulative frequency curve instead of a regular frequency curve? Please take a few minutes to think about your answer. Compare your conclusion with the classmates.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I wonder what answers you came up with. One reason to use a cumulative frequency curve is because it is a good way to determine values that are less than or more than any reference value in the range of data. In a cumulative frequency curve, you can quickly see how part of the population relates to the whole. It is also easier to view trends on a cumulative frequency curve. Today, you have learned 3 new ways to represent statistical data. You have learned how to construct a histogram, a frequency polygon, and a frequency curve. In our next lesson, we will learn about bar charts, line graphs, and pie charts. Until next time, thank you, teacher. Thank you, students.